So this is paper 4, set 2. The first one is air is pumped into the rocket so that the pressure of the air inside the rocket increases. Explain in terms of the particles why the air exert a pressure inside, pump into the rocket so the pressure of air inside the rocket increases. Explain in terms of the particles why
I can do this no matter what and use.
the air in the rocket exert a pressure on the walls. So first thing we'll mention, air particles are moving randomly. The first point which we will mention, we relate the motion of the air particles. Air particles are moving randomly. Then due to the random motion, they will collide with the walls and each other. So collide with the walls and each other. And as a result of a collision, it will exert force on unit area. And when it will exert force on unit area, it will create a pressure. So screen annotation, I just switch off screen annotation for some time because I was not able to remove that. So that's why just only for some time I switch off. Once it is normal, I will switch on again. The temperature of the air in the rocket remain constant. So you can use a chat to answer your questions and I will copy here. The temperature of air in the rocket remains constant. Temperature is not changing. As the air is pumped into the rocket, explain why increasing a number of the particles increases the pressure. So as we increase the number of the particles, so more particles are there, so they will have more frequent collision. Because greater the number of the particles, more frequent collisions are there, or more collisions in unit time. That's why the pressure will increase. So more particles leads to more collision per unit time. So remember one thing, the pressure exerted by the particles depending on how hard they hit the container and how many are hitting the container. So it depends, the pressure depends on how many are hitting the container at once and how hard they're hitting the container. So these two will affect the pressure. Yeah, if you mention they collide with each other at a higher rate, which increases the pressure, that is also right. Next, in part B, the air pressure in the rocket is high. The rubber tubing is removed from the rocket. A water in the rocket is expelled downward in terms of the momentum why the rocket begins to accelerate. So what we did here, look, once we pump the air, we remove this rubber tubing. So this rubber tubing is removed. So there's a high pressure from the air, like there's a greater pressure from the air. As a result, it pushed the water outward. So water will go out, and what we observe the rocket is going upward. So we have to explain in terms of the momentum that how the rocket moves in terms of the momentum. So you have to use a conservation of the momentum. We'll say the momentum is conserved. So momentum conserved means that momentum should be same. Even it's an explosion, even it's a collision, the momentum should be conserved. So first point we will mention the momentum is conserved. Conserved means same. Like momentum before and after should be same. So if the momentum before is zero, the momentum after is zero as well. So in the case momentum is conserved, the initial momentum is zero, like the starting the rocket was not moving. So if the initial momentum is 0, the final momentum should also be 0. So if initial and the final momentums are 0, the final should also be 0. So if the water is going downward, the rocket should move. The rocket should have equal momentum but in opposite direction. Or the increase in momentum of a water will be equals to increase in momentum of the rocket. Like if the water momentum increases by 30, the rocket momentum should also increase by 30, but it will be upward. So that's why the rocket will accelerate upward. This is a rocket propulsion. What is the meaning of the term momentum is conserved? The term momentum conserved means the momentum before is equals to momentum after. So because the rocket was initially not moving, so finally when it start to move, the momentum of the water, the final should also be 0. So if the water which is going downward, let's say it's having a momentum of 50, so the rocket which is going up should also have a momentum of 50. If you say, can we write upward momentum is, yes, you can say upward momentum is equals to downward momentum. But in using a term, momentum is conserved is very important. So momentum is conserved. So the initial momentum, like the upward momentum is equals to downward momentum. That is also fine. But the most important thing is mentioning the momentum is conserved. This is for part B. This is for part B. We'll say the momentum is conserved. The water momentum is downward. So the rocket will have equal and opposite momentum upward. That's because of this, the rocket will accelerate upward. Because of momentum, there will be a force on the rocket which cause an acceleration. As the water is expelled from the rocket, the upward acceleration of a rocket changes. So there's two reasons for change. Look, first thing what happened, First thing what happened, the momentum of the water was downward, so the momentum of rocket is upward. So because of the momentum of the rocket, there's an upward force. Like there's an upward force. And we know the formula F is equals to ma. So the resultant force depends on the mass. Because the water is coming out from this rocket, so the mass is changing. If the mass is changing, so the resultant force or the force on the rocket will also change. That is one of the reason. Because if the mass is changing, the force, resultant force or force will also change. That is one thing. What about another thing? Because as the rocket is moving through the air, like in the surrounding, the air is present. So as the rocket is moving, air try to oppose the motion of the rocket. So as the air try to oppose the motion of the rocket, the resultant force will also decrease. So two reasons we have to mention. One is the mass of the rocket is not constant. That's why the force of the rocket is not same, or force on the rocket is not same. The second is as the rocket start to move, the air start to oppose the motion. That is another thing. Or you can also say the air pressure inside, like because number of air particle decreases, so air pressure volume is increasing. So the pressure of the air is decreasing. So the pressure at which the water is coming out, that is also decreasing. So that is another reason you can relate. The rocket mass is changing. That is one thing, and the air resistance acting, that is another. What is another thing you can add up? You can also say that the pressure of the air which is acting on the water is also decreasing. Why? Because as the amount of water is decreasing, the air will have a large space. The air particles, the same number of air particles, but with a large space. As the volume increases, the pressure will decrease. So as less pressure, less upward force will be there. That is also causing a change in the force on the rocket. So you can mention that as well. Is it clear?
Yes, sir.
So pressure decrease, yes, you can mention pressure decrease as well. Pressure exerted by the air. Yes, I will repeat. Look, in the question, they're saying why the resultant force or the force on the rocket is decreasing or changing. They did not say decrease, but it will decrease. The two reasons why the change in acceleration. Why the acceleration change? Acceleration depends on what? Acceleration depends on what? Acceleration depends on the force and it depends on the mass. So F over m is equals to A. First, how the force will change as the pressure of the air is changing because the water is coming out from this. As the water is coming out from this, so as a result, this will have a smaller, because a large volume, so smaller pressure. So this will have a smaller downward force as a result of smaller upward force. So the force on the rocket is changing because the pressure of air inside the rocket is decreasing. That is one thing. The second thing, as the water is coming out, the mass is also changing. If the mass is changing, the force on the acceleration will also change. Another thing, as the rocket start to move, there will be air particles which will hit the rocket, and these air particles oppose the motion of the rocket. That's why that will also call a change in acceleration. If I write the momentum of a rocket changes, result, no momentum, but you have to state, yeah, momentum of a rocket, momentum of the water changes, that is causing a change in momentum of a rocket. So the force changes. But it's of 2 points. So you can mention many points related to this. Air resistance, you can refer the change in momentum of the water is not same. You can say the mass of the rocket is not same. You can say as the rocket rise, there might be a change in acceleration, gravity. That will also cause a different acceleration. To define what is meant by the term acceleration, acceleration is a change in velocity per unit time. That is a 2-mark definition. 1 mark is for referring. 1 mark is for referring the change in the velocity, and 1 mark is for referring the time. As a lorry moves forward, the work done on the um, uh, work done work is done on it by a driving force. Write an equation that defines the work, refers to a direction of a force. So work done is equals to force into distance in the same move in the same direction. Refer the direction of the force exerted. So work done is a product of force and distance in the same direction. Yeah, distance in the direction of the force. Parallel to acceleration, no, no, not correct. No, no, not force downward. The rule is that, just a minute, Ayan. Let me just move on to the question, then annotate. Because I'm still discussing B1. So refer the direction. So whenever we talk about the work, it is a force and the distance parallel to the direction of the force, or same as the direction of the force. That is the actual definition. Calculate a work done on a lorry by driving force when the lorry travel a distance of 280 meters. So how you carry out find the work done? The constant driving force is given 4.5 exponent 4, that is the driving force is given. And you have the distance moved, which is 280. So when you multiply, you will get the answer in joules. 1.5 exponent how much? So 1.5 exponent 7 joules. Joule J is already written, so you don't have to write. So just 1.5 exponent 7. As the work done is a product of force and distance. Now, at a point on the road, the kinetic energy of the lorry is 3.2 exponent 6 joules and the speed is 12. Calculate the mass of the lorry. So you have to use the kinetic energy is equals to half mv square. The kinetic energy is 3.2 into 10 to the power 6. It will be 1 by 2. The mass is unknown. And what about the speed? When you write the answer, always write your answer in 3 significant figure. So like if it is 1.517, so round it off to 1.52 exponent 7. So the speed is 12, so this will be 12 square, which is 144. So 2 will be multiplied and 144, and then this will give us the mass, which is 4.4 exponent 4 kilogram. You can take from here. Question 3. When the temperature of a liquid increases, the kinetic energy of its particle increase and the liquid expand. Explain by referring to the particle why the liquid expand or when heated. So what actually happened? As a particle heated, they gain kinetic energy or move faster and more distance. But what are the precise, what is the, that this is fine, but the precise answer when you want to write precisely, as you supply the heat energy, the particle move faster. So the forces of attraction between the particles get weaker. So, or less force of attraction between the particles, so they will move away from each other. So the important points, like I'm not saying answer being wrong here for the students, those who annotate. I'm just saying the precise points what you should refer here, because they already mentioned temperature of liquid increase, the kinetic energy of particle increase. So this is not having any marks. This is already there. What I have to refer is when we increase the temperature, so when we increase the temperature, what will happen? The forces of attraction between the particles decrease. As the force of attraction between the particles will decrease, so as a result, what will happen? The particles will move apart or particles will move away from each other. Liquid is a weak inter between the bonds, so in which no need to refer the type of the force. You just have to say that the force, when you supply heat energy, even if they ask how the solid, if they change the question and they said about the solid. So even if the same question was there about the solid, Jan, wait a minute. I am discussing any other point. So I'm not discussing a question, a related question I'm discussing. So if we have a solid here, so if they say when the temperature of a solid increase, the kinetic energy of particle increase and the solid expand. So what answer I will write? I will write the same answer. What will be the structure of the answer? I will say in a solid, when we supply heat energy, the particle attraction between the force of attraction between the particle decreases. So the particles move away from each other, the solid expand. If the same question they ask for the gas, I'll write the same answer. Then I'll say that when we increase the temperature, the force of attraction between the gas particles decreases. So it's already weak, but it decrease. If they ask us a question why gases expand more than liquid or a liquid expand more than solid, then we will compare the strength of the force. Like I will say, because the gases have a weaker intermolecular force as compared to that of a liquid, or liquid has a weaker than solid, then I will refer the strength. But in this case, I don't have to refer the strength. This is a very general, generic question in which they ask us what will happen if we supply heat energy to a substance. So it has nothing to do with the liquid. It has actually the question is related to what will happen when a substance is heated. Moving on to the next question. The heater in a kettle is near to the base. The heater in the kettle is there, which is near to the base. The kettle is filled with the water at a temperature 17. So the temperature of the water is 17 degrees. State the name of a method, thermal energy, that causes the energy to be transferred to water that is touching a heater. So if the water was touching a heater, when two different materials are in contact with each other, how the energy will be transferred, like heat energy will be transferred by conduction. So conduction is by a transfer of heat energy between the two materials, or when the two materials are in contact with each other. The next is how thermal energy transferred through all the water in the kettle. So how thermal energy is transferred? So as it is heated, the density of a hot water will decrease. So hot water will rise and the cold water will sink. And this cycle continues, set up a convection current. Or when water particles gain a thermal energy, the kinetic energy from the base of the kettle, the high energy particle becomes less dense due to they will rise up to the like goes up. With high temperature will have a low density, and low temperature will have a high density. And this continuous movement of the particles will set up a convection current. So you have to set up a convection current. By convection, as the water particles at the bottom are less dense, so due to the gain in kinetic energy, they move to the top. Yeah, this is also right. Correct. State the boiling temperature of a water at a standard atmospheric pressure. Include a unit. The boiling temperature of a water is 100 degrees centigrade, or standard SI unit is of a temperature is a Kelvin. 100 degrees Celsius, but I should write as 373 Kelvin. It is acceptable, but SI unit is Kelvin. That's why we are writing in Kelvin. The SI unit of temperature is not degree that we use for our convenience, but SI unit is Kelvin. The next question is related to the specific heat capacity. The second part, which part? This one? How thermal energy transferred through the water? How thermal energy is transferred through a water is by convection. What will happen? The particles which gain energy at the bottom, they will have low density, so they will rise up. So those particles which are at the top, they are cold particles, low temperature, so they will, because they have a high density, it will sink. And this will set up a convection current. So how you will score the mark? 1 mark for mentioning the hot particles or the heated particles of a water will have a low density, so they will rise up, whereas cold particles or a particle with a low energy have high density, it will sink, which set up a convection current or transfer the energy throughout the water by convection. So one is for hot particle rise, 1 mark. One is for cold particle low density, high density sink, and one is for using a term convection current or a convection. A kettle contains 2.5 kilogram of a water. So we have the mass. The specific heat capacity is 4,200. So this is C. When the water reaches the boiling temperature, the switch off, calculate the increase in internal energy. So E is equals to Cm delta T. or delta theta you can also use. So specific heat of a water is 4,200. The mass of the water is 2.5. And one more thing, like whenever you see a question, if the mass is given in kilogram, like specific heat is joule per kilogram, mass should be in kilogram. But if it was joule per gram, then the mass should be in gram. So it is very important that this they should have the same units. And the temperature, it was originally 17 and rises to 100 to a boiling temperature. So 100 minus 17 when we multiply. When the answer is too big, the best way to represent is a scientific notation, like standard form you should write. So this is the right way of representing an answer to be very large, big or very small. So 8.7 exponent 5, that's appropriate way of representing the answer. The next question, a red light of a frequency 4.7 exponent 14 hertz in air at a speed of 3 exponent 8. So we have the speed and we have the frequency. So we'll use a wave equation. V is equals to F lambda. So lambda is equals to V divided by F. So speed of a light divided by speed of a light in air divided by the the frequency. So we'll get the wavelength, which is 6.4 exponent negative 7 meters. The next question, figure 4.1 shows a narrow beam of a red light strikes the surface of a parallel side glass block. State what happened to the speed. Look, as it moved from air to glass, what happened to the speed? It decreases. What happened? Because in air it is traveling faster, but in a glass it travels slower. So there will be no change of a frequency. And what happened to the wavelength? The wavelength will also decrease. The ratio of the speed and the wavelength remain unchanged. So when the light travels from air to glass, the speed decrease, the frequency stays the same, and the wavelength decrease. And if it was opposite, then we'll write increase stays the same, and then show refractive index. We need the refractive index, which is a ratio for speeds or angles. So we use a formula. It is moving from air to glass. So we'll use a formula sine angle I over sine angle R. So angle is always from normal. So angle of incidence is given 45. If the wavelength decrease, the speed will also decrease. If the wavelength increase, the speed will also increase, but the frequency remain unchanged. So if, as the light speed decreases, its wavelength will also decrease. So sine angle I, the angle of incidence is 45 and angle of refraction is 30. So sine 45 over 30, it is 1.41. Another important point that in exam, it has no unit because it's a ratio. And another important point, always check the mod of your calculator when you're using, like in exam, all the angles should be in degrees because your mod of calculator can be radian, can be degrees. So it's important then when you enter the exam, before you start your exam, convert the mod of your calculator to degrees if it is in radian. When do we use sine R over sine I? How do we know that? On your calculator, first I will answer that question. As one of the student asked when we will use sine R over sine I, this formula is valid if a light is moving from glass or water to air. Like from a high density to low density, this formula. But low density to high density, sine angle I over sine angle R. An easy way to remember this, that always remember the numerator angle should always be greater than denominator angle. So it's always like even if you, for example, in exam you forget whether it is I over R or R over I. Just one thing always you will keep in mind, that the numerator angle should always be greater than denominator angle. So here I have two angles. One is 45, one is 30. So which one is a greater angle? So 45 is greater. So I will use sine 45 over sine 30. But if it was traveling in this way, like the light was in glass and it was going into the air, and the angles were given. So this angle was given 60 or 40, and this angle was given, let's say, 60. And I will need a refractive index. So what will I will use? Again, it's always a greater angle, so I'll write sine 60 over sine 40. That's it. Numerator angle is always greater than the denominator. That's it. Is it clear?
Yes, sir.
Yes.
Okay. A light continue along the path in figure 4.1 until strike the bottom surface. The light then emerge into the air. Draw on a figure, show the path taken by a light until it strike the bottom surface and the path of a light that emerges into the air. So what they mention here, they mention we have to just complete the path. What about on your calculator, you will have a mod on your calculator. It's a degree is there or radian. You press shift mod. This is not the right one because it should show bend away from the normal. Because moving from air to glass, like this will continue, but when it moves from glass to air, it should bend away. So no, this is also not correct. It will not go to other side of the normal. It should be because it cannot emerge out in this way. So the correct direction is, if you complete here, then moving from glass to air, it will bend away from the normal. And the one more important thing in a rectangular glass block, the ray which enter and the ray which emerge should be parallel to each other. So means this ray which is incident and which ray that emerge, I should draw them parallel to each other. Yes, I'll repeat. When a light is, we have to complete the path of a light. So first, we have to complete this path. The light is going, it will hit. When the light travels from air to glass, glass to air, it will bend away from the normal. So this is bending away from normal. And how to know? If I draw the normal here, this is representing a normal. So it should bend away from the normal. And when it emerge out, the ray which is going out, the emergent ray should be parallel to the incident ray. Right? But I don't have to draw this line. This is just a reference what a student drew. This is fine, but in exam, you're not supposed to draw these lines. You have to erase this. You can just use a reference to make a parallel. Is it clear? This one? If the question was sketch a path for a green light, what will the path of the green light? If they say sketch the path for a green light. So complete path of a green light, if it is strike, so green is having a higher frequency than red. So it will bend more and then it will bend away. So it will have a greater change in the direction. Yeah, Vibgyor is there. Violet is having the highest frequency. And the red is having the shortest frequency or the longest wavelength. And question 5. Most of energy emitted by a sun is in the 3 regions of electromagnetic spectrum. Name one of the three. Name of the one of these 3 regions is a ultraviolet. State the name of all other. The smallest frequency, because the sun is giving us heat radiation. Infrared radiation is having the smallest frequency. That's right. The visible, which the only part which our eyes sensitive and we can see, that is a visible. And then a UV, the highest frequency, that is the ultraviolet radiation. The next is sum of the UV radiation emitted by a sun reaches, can we write UV in which part? The first one? Yes, you can write UV, ultraviolet radiation. In ultraviolet, UV is acceptable there. It's like a precipitate, you can write PPT. Ultraviolet, you can write UV. So give one possible damaging effect that UV radiation on the human body and the property of UV radiation that causes this. So it can cause a skin cancer, can cause cancer by mutation of the cell, or okay, is that it can cause a cancer to, and then what property is there? The properties of these radiation, obstacle, and it's very dangerous. What is obstacle? It can pass through any obstacle, okay. So what the main thing is, the radiation can cause ionization. So the most appropriate answer is ionization here. Yeah, damaged skin, and what property can cause this damage, you should use the term ionization. Like if they say why alpha particle is dangerous, beta is dangerous, gamma is dangerous, you will say it is ionization. That is the most appropriate thing about radiation. So damaging effect can cause a cancer, is any type, and property is the ionization. When we are talking, taking an X-ray, the hospital, the doctor give us a coat to wear which is heavy. Why is that? The main reason is that because X-rays are also electromagnetic radiation. Even the technician who's conducting like taking the X-ray, the film, that he's also either he's using a protection or he's going out from the lab for a moment when the person is exposed to the X-ray. Because these radiations, a long-term exposure to the radiation can cause cancer or a mutation, and the main reason because they are highly ionizing. These radiation cannot pass, X-ray cannot pass through a metal or a bone. That's why the coats which are there, it should be metal, like having a metal lining, so that it will protect you from the ionizing radiation. Electromagnetic radiation is a transverse. What is the difference between a transverse and a longitudinal? The transverse wave consists of crest and trough, where displacement is parallel, okay, and the direction of the perpendicular to the direction, or a right angle, where longitudinal wave consists of compression and rarefaction, and the direction of propagation, like a vibration of a particle, is parallel. So this is a question you will find in exam, a common type of a question. So try to learn the standard, the structure answer for this. For those like students wrote, that is all correct. So transverse wave vibration perpendicular to direction of wave include crest and trough. Longitudinal direction is parallel to wave include. Can we say crest, trough, and no? You have to include. You can include that, but the important point here is a direction of a vibration and the direction of the wave. The direction of a wave is direction of vibration is perpendicular to the direction of the wave. So less than a minute left. You will join from the same link, and we'll continue discussion. So we'll try to complete this mock set 2 today so that we can discuss the remaining 2 tomorrow. So join from the same link.